outside. So it's not much room for everyone. So my name is Aris. I'm going to present you a few things about SSH and TLS SSL, and more in particular over SSH. So library to access the SSH protocol. So a few words about myself. Okay, I'm a geek, you can see it. I'm a security and cryptography enthusiast. Hacking enthusiast as well. I work for the lead SSH project. I work at Belnet, which is a research and education internet provider. So we provide internet connectivity to research network, and in particular to FOSDEM this year. There is a job booth, so if you have an image, just go there. That's for my advertising. Okay, I'm Belgian, and I like it.
Just tell me where you want the next slide.
Sorry?
Just tell me where you want the next slide.
Okay.
Press that you don't have to.
Yes, but my whole slides are interactive, so I will do it. Okay, so I'll start by speaking a little about the differences between SSL and SSH, because I'm not sure it's clear for everyone, and it's a good start to decide if you are going to use SSL or SSH for your next cryptographic application. And then I will talk a little about our project, how it works, and how to use it in start. So you can start coding your own SSH client when going outside of this room. So, you know SSL, you know TLS. How many people here know the difference between SSL and TLS? In fact, there is almost no difference, yes, because starting from 3.1, SSL is the same as TLS 1.1, but I think it evolved since then. Okay, there is SSH1, which is almost legacy. It has plenty of hole inside it, so nobody uses it anymore. Maybe in some old Cisco routers. And SSH2, I imagine most of you already use SSH. So, what's SSL and TLS? The name is Secure Socket Layer, Transport Layer Security. So the idea is really that it's a secure transport. The goal is to transport data from A from B to B in a secure fashion. So it was developed by Netscape. I think the version 1 was broken during the presentation. Yes, but they came with the version 2 quite quickly. Okay, it's really used for HTTPS, FTPS. I think you know it. Something that's interesting is that the security model of SSL and TLS is based on X5 honor certificate. So that certificate you buy at some CA providers for a lot of money generally, and they say you are to be trusted because you gave them money and a proof that you are who you are. Sometimes, yes. So there are lots of implementations. So the best known are PNSSL, GNU TLS. If you are using Firefox, you are using NSS. There will be talk about SSL as well. And I think Windows has its own implementation. I think a complete list would include 30 or 40 libraries. So it's very used. Okay, what about SSH? Is a secure shell. So the primary use of SSH was to provide an interactive shell to a server. The goal was to replace Telnet, in fact. that was insecure at the time. Okay, a lot of, yes, the first version was SSH1, which was almost free software. The OpenSSH team took the code when it was still free, and they've made the great OpenSSH project. So it's defined in RFCs. It's recent, quite recent. I think it has been done 1 or 2 years ago. So some of the features of SSH that outgrow the general scope of SSL are that, well, a secure transport you have that with SSL as well, but with several channels for the communication. So it's possible to have parallel channels of communication in the same SSH stream. It's important. Authentication is embedded inside the protocol, so it's very interesting. I will tell about it later. Okay, so it was done for the shell handling, so everything that goes around terminals, terminal size, X11 forwarding, and so on. That's embedded into the protocol. And there is also dedicated file transfer protocol that is a lot different from FTP because it's based on a binary protocol. I won't go into the detail because it's a little out of time. Okay. What are you looking into a security protocol or a secure transport protocol? Of course, you are looking for integrity. You do not want that someone with his laptop can change something in your data stream and corrupt your files or inject commands into your shell. So a good thing for a transport protocol is that any tampering is detected and, if possible, is avoided. You look also at the availability. Availability is a resistance against denial of service attacks and the fact that you have the most uptime as possible. So it's not possible to shut down your connection, to make it look slow, to stop you from connecting to your server and so on. Something you want as well, and I think it's the best known functionality of SSH and TLS, it's a confidentiality. You don't want anyone to know what you've done on your interaction on your channel. So nobody can withdraw you. And that implies that you are sure who you are speaking to. That's very important because if you are sure you are talking into a private and secure channel without anyone eavesdropping, but you are not actually speaking to the good person, it has no interest. So it must be embedded into the security of your protocol. Most of implementation of SSL and SSH do the same, apply the same solution for all of these programs. So integrity is verified through strong hash maps. So it's a cryptographic mechanism that makes it possible to verify that a packet has not been tampered with. Another problem is that if somebody change a byte or a bit, flips a bit into your stream, SSH or TLS will detect it and shut down the communication. So much for the availability. It's still based on TCP, which is an insecure protocol. So anybody can send an RST, anybody can send a packet containing garbage, and the application running SSH or TLS will not be able to recover from such a situation. So if you are looking for availability, SSH or TLS is not your solution. Maybe you should look at something run on top of IP like IPsec. Okay, confidentiality. It's actually a well-known problem. So strong ciphers, a key exchange, and of course the authentication on the key exchange. The key exchange is the way by which the server and the client agree on a common symmetric key to use for the communication, and by a way or another, the servers might tell, I am that server, and my proof is that I signed the key exchange. Yes. Okay. So the main goal of server authentication is to avoid the man-in-the-middle attack. Man-in-the-middle attack is when someone runs right between your server and the client, and they fakes the server. So in TLS, well, I won't go a lot in the details because I think it's not really the topic right now. But there are lots of difference between SSH and TLS. For instance, TLS is using X509 certificates, where SSH only use key H's. So you connect for the first time on your server and you get a hash. Do you trust the server to have that hash with a cryptic MD5 or SHA1 hash of the public key? And you say yes or no, and then you store it on your computer and you identify it. And you store it on a non-host file, which is a big difference between TLS, which use a trust chain to verify that the host is legitimate.
Additionally, their OpenSSH started using certificates. They're not X509 certificates, but their own certificates.
Yes, that's right.
A while back.
They started implementing their own certificate at first because they felt the need for certificates because people having huge farms with hundreds of servers don't take time to exchange and load those files. But they favored it, the X509 thing, because they thought a lot of vulnerabilities could come from just parsing X509.
So X509 is maintained by Ruben Pro as a separate patch out of the tree. And the certificate support that is added in OpenSSH since a few versions back now is really much simpler. It's just the keys and just signatures on keys, and they intentionally did not use X509 because it's complicated.
Yes, it's really complicated. It's easy to make errors.
Yeah. But it's new still, so
yes,
let's see how it goes.
That's quite recent. Okay, now something that is important as well is that the server must sometimes know the identity of the client, the guy who is tapping something on the keyboard. So with TLS you don't have so much choice. Either you must use a certificate as well. Of course, you can use a smart card with efficacy as well. But if you wish to use passwords, OTP, two factors, and CISO, you are left to use the application layer, so HTTP or FTP or something else. There is nothing integrated right into TLS for that. And that's a big difference between SSH and TLS, is that in SSH, everything is done inside the protocol to just to run.
Yeah, you can use PSK now in TLS.
PSK?
Yeah,
Crucial key. Yes, that's interesting too. I'm not sure you can do it with SSH right now.
No.
Okay, so interesting. Okay, so I'm sorry if the diagram is not really nice. I made it in a hurry. So that's a little chin-up of the difference between SSH and TLS. In SSH, you have several channels that can be used to communicate with the server. and each channel is dedicated to a service. So for share, for roaming, and all of the channels are protected using an authentication layer particularly used to authenticate users. So if you wish to use OTP authentication, just use keyboard interactive. So it's possible to ask to send a challenge to the client, and the client replies using the OTP. There's also GSS API, which can be used for Kerberos integration. So, what are you going to choose? I'd say it depends on your trust model. If for you a CA model is easier, if a lot of people are going to use your service and there is no problem that China can forge certificates for you, then TLS is probably the best protocol. So it's a very good. That's one use case. You'd use SSH if you have a clear use of an asymmetrical protocol. So there's the servers and the clients. They are mostly the same, but there are differences in the implementation. The host authentication model is very simple. So most users will just have to click on accept the first time, and that's okay. Yes, OpenSSH, you can find it almost everywhere. And it would be a good idea to actually implement SSH for the access to some widely deployed system services like IMAP. Why couldn't a user have access to IMAP using all the advantages of the authentication feature of SSH? So it's time to start implementing I will have to hurry a little. So that's a list of existing SSH library. You can see LibSSH is not the only one. Actually, I did not test all of them, and I can guarantee the whole one. But it's interesting to look at it. Okay, now I will speak in detail about LibSSH. So it's just started like a simple SSH proof of concept in 2003, and I started putting some code around to make a library for SSH, and then it became a little more serious. Some people were contributing. Andreas, which is there, came in 2008 and made a lot of work on the code, but also on the infrastructure. So now LibSSH is around 33,000 lines of code. So it's 1/3 of OpenSSH. And it's used by some free software like TTK. Okay, so interesting feature of LibSSH is that it's client-side and server-side as well. So you can implement both sides of the communication. There is support for SSH2, SSH1. You can authenticate using password, that's the most used of LibSSH, but also keyboard interactive. For instance, if you have PAM on your system, it will rely on keyboard interactive. Public key. So if you have public key on your system, it will try to authenticate using it. It will also try to authenticate using the SSH agent. And the good thing is that if your SSH agent is already compatible with PKCS level, you can also authenticate using a smart card. Okay, OpenSSL, JetPrint, Windows Phones. Okay, a lot of basic features from SSH. Okay, we also wrote a lot of documentation for libSSH because we felt it was really important for libraries to be correctly documented. So if you want to have a look, the API documentation and Doxygen documentation is available on that URL. There is also a tutorial that explains all the basic steps to get things done, but I will show you a few steps of code. Okay, there are also a lot of examples. It's not intended to be video, but let's look on the main page of the tutorial. So there is an explanation of how to connect, how to authenticate, how to open a remote shell, SFTP, STP, providing connections, so TCP providing, how to handle trades, and you are currently writing a tutorial on the server communication. Okay, we are developing libSSH on our own hardware, on our own infrastructure. So we are using Git, Redmine, and what's interesting, we have a test panel with night bursts. So every night there is a build that is done on several targets. Tests are run using Valgrind too. And so we get a mail each time someone broke something. So you can have a preview. That's how it looks. So on content use FreeBSD, CentOS. Now we have Windows as well. And we get a lot of bugs fixed just by using this and getting the bugs reported by Windows. So it's very, very interesting. Another thing that is interesting is the coverage of the test. So all the tests cover some part of the code. Right now you can see it's still orange because we only have some 30% of the code that is correctly tested. But we only started 1 or 2 years ago to do some systematic testing. So it's not that bad. Okay, so now the details of the coverage. Okay, that's an example of how to connect to SSH. Actually, it's pretty straightforward. So you just create an object for the session. You just tell, I want to connect to localhost. I want to use the login Paris. I connect, and then I check the return code to see if the connection was successful or not. Okay, then I need to check if the server is known. So just like on OpenSSH, when you connect to your host, you get an error message if you are going to connect to a server whose key has changed. That's the same, you just get an error code that tells what the status of the host in the known host file. So server known, okay, everything is good, the host is known. Server known changed, that means the key changed at very bad. Server front order, that means the server advertised a DSC key, for instance, but you only know the RSA key. File not found and server not known means that's the first time you connect to the server or that you are using SSH. And in that case, you just have to update the file.
So, question?
Yes?
Is it using the OpenSSH known host file, the same format and the same?
Yes, same
file?
format.
Same file.
Parsing it the same way. We parse also the configuration file from SSH. It's not complete, but we are, well, I say, 70%.
No.
No?
Maybe 30%.
And the 30% is, I'm optimistic. Okay. No, you need to authenticate. Well, there is an interesting code that does everything for you. It's user auto top-up key, which simply try all the public keys in your repository and we'll try to connect using it. If you still need to connect using the password, there is a straightforward password authentication code. But of course, there are a lot of more. Yes, I will go. I will hurry. There are a lot of other codes that can be made for lower level authentication. Okay, now you want to just execute something on a channel, but you have to create a channel to open it. So you have to ask the server if you can access it. Normally you should look at the error code each time you do SSH call, of course, but here it was stripped down for the example. So you just request some execution of the command, and then you read the response. And when you are done, you close the channel. So it's pretty straightforward. Now, what we are looking for the future, we are planning to become 100% SSH library. So we want to implement 100% of the SSH protocol. That's not the case by now. We want to be fully asynchronous codec-based. Right now, a lot of work has been made in that direction, but it's not ready yet. So we want an all-working API. It will probably be ready in a month or two. Okay, I would like to go into other languages, but still some work to do. PKCS 11 is a hot topic because we are here just to speak on PKCS 11. Right now, you can use libSSH with PKCS 11 for using the SSH agent, but the support will be ready in 1 month or two after. Okay, and of course we have some work to do on the SSH part, server part of libSSH. Okay, I'm just in time. I don't know if there are some questions. Yes?
Is it a server or client side?
Both. So the client side API is more evolved than the server part API. But as far as I know, libSSH is the only SSH library that does the server part. Yes?
Why did you implement it as a separate project from OpenSSH, taking the library out of OpenSSH slowly?
Probably the not invented here syndrome. Yes.
Our comment to that is that the OpenSSH code base is not really, well, you could make a library out of it, I guess, but it's not made as a library.
It's not the same concept. The concept in a library is that you must have an external API to access the whole elements, while in OpenSSH everything is done to work inside OpenSSH, so it's not really the same. Maybe we could share 50% of the code, but not that much.
Well, I have a question. Which is the most widespread user of libSSH?
The KDE project. So if you are using KDE on SUSE or so Ubuntu and access using Dolphin SFTP folder somewhere on the server, we are using libSSH as backend.
Okay, that's actually, it was a trick question because I think I once shared with you that there was a document that said that libSSH is the most used client for some botnet.
That's right. That's right. So the most.
We are the market leader there.
You want to start somewhere. That's right.
Low hanging fruit. So, okay, time is up. Thank you.
Thank you.